Hi, this is going to be another example for 3D equilibrium. Last time we look at one that has a bucket that's tethered by 3 wires. And this is another example for 3D equilibrium. As you can see, to solve each problem, it takes some time, right? And it involves the concept of 3D force along a line, and also involves the concept how to solve linear equations. So I think it's worth for us to look at another example here. They said there's a bucket of fish that has a mass is 200 kilogram. Well, mass is not a force, so we have to convert that, find the weight. So weight is equal to mg, and 200 kilogram times 9.8. That will give us in newtons. So I think that will be this, right? 1960 Newton. All right, so knowing that, we're going to solve this problem. They want you to find the forces in the cable and the direct legs. So basically, if the force weight is going downward here as 1960, and all those forces, to be honest, I'm not sure what direction, but likely this tension is going down this way. But here it really doesn't matter. Remember when we talk about 2D equilibrium, when you solve equation, you find your answer is negative, and that negative answer corresponding to this FBD you draw, and it's a pair, they go together. If it's negative, only means the true direction is going to be the opposite direction you draw, right? So any engineer, when looking at the work, they will understand exactly what the true direction is. So there's no way to panic, just leave as it is. If it's negative value, that's it. And here I am, for example, I'm guessing this one is going downward. I'm guessing TAB is actually going upward. So what I'm assuming is going to be along this line. So extend this line, and that's going to be pushing upward. Okay. So it's from A to B. This is my guess. Then we also have this as TBD because it's from B to D. And this is going to be from B to C, TBC. Okay, so those are the 4 forces. I kind of randomly choose the direction, which is totally okay. Now let's go ahead and solve them. First of all, we're going to figure out TAB. TAB is force along a line. We do not know this TAB, it's unknown. Then it's AB, position vector, over distance. So TAB, position vector from A to B. So it's a final B minus A. And do we have a coordinate? We do. Origin is right here. And our X direction coordinate is here. Our Y is that direction. And this is our Z direction. Okay, so it's B minus A. B in terms of X looks like B is located in terms of X direction. It's actually coordinate as 0. Looks like a B is on YZ plane, okay? If B is on YZ plane, X is equal to 0. So when you have B minus A is actually at 2 in terms of X. So it would be 0 minus 2. That's going to be our I term. And now let's look at the J term. J term in terms of Y, again, it's B minus A. Y is this direction. B is 4. And A is on x-axis. So A coordinate for Y is 0. So it's 4 minus 0. That's going to be our j. Now let's look at our k term. B is higher than A. How much tall? How much higher? 4. Because B is 4. Again, 4 minus 0. That's our k. So we got expression for AB, right? AB position vector. Now we're going to just figure out magnitude 2 squared plus 4 squared plus 4 squared. Let's see, what do we have? We got a very good number, 6. So that's a 6 meter. Then we plug this in. Negative 2 over 6 will be negative 3. Negative 1/3. But don't forget, we need the times TAB. That's our I term. Our J term will be just 4 over 6. That's 2 over 3 times TAB, our J term. Our last term is also 4 over 6. That's 2 over 3, our TAB, our K term. So we get expression for our TAB. Now the next thing we're going to do is our TBC. This force right here. TBC. Same thing, TBC magnitude over position vector. All right. So position vector needs time to think about, right? So it's from B to C. C minus 2, final minus initial. Now let's take a look. It's x coordinate difference. C is behind, it's on negative. X, how much behind? This one, this value, negative 2, because x direction here. And B, however, is on YZ plane. If it's on YZ plane, that's 0. So C is negative 2 minus 0. That's going to be our I. Now let's look at our J term. J is this direction. Again, our J term for C is, okay, so for J term, we're going to look at C minus B, and the C minus B. C happen to be on this x-axis, and it's on negative x-axis. But regardless, the y-coordinate would be 0 since it's on x-axis. So it would be 0 minus our B coordinate for B, our y-coordinate for B, which is 4 right here, right? So 0 minus 4. All right, now let's look at the K term. From B to C, so it's C minus B. C, again, it's on x-axis, so it will be 0. And K, and the Z coordinate for B is high, so it's 0 minus 4. That's the coordinate difference for that. Okay, so now we can go ahead and find the magnitude. So it's 2 squared plus 4 squared plus 4 squared. And we know that will give us 6 meters also for this problem. All right, then we're going to simplify that. For the I term will be negative TBC over 3 I. And for J term is negative 2 over 3 TBC J. For the K term will be negative 2 over 3 TBC K term. Okay. All right, so we're getting close. We're gonna figure out the third force, TBD. TBD. So same thing, same concept, TBD, and BD position vector over BD distance. All right, let's figure out the BD coordinate difference. B is right here, D is right here. We're using D minus B, final minus initial. So our X coordinate for D is on y-axis. So that's going to be 0 for X coordinate. And our B is located, where? B is located on YZ plane. So X coordinate is 0. So it's 0 minus 0, I. Now let's look at J term. J term is on y-axis right here. And D is, well, D is behind. How much behind? This value, negative 5.6, and we're gonna minus the B coordinate for y is 4. So it's them together, the difference between them. So we'll have 5.6 plus 4. However, it's negative because D is behind. Now we're gonna look at the K term. K term is Z direction. It's this direction right here. And so we're going to use D minus B. D is below, B is higher. It's 4 meters higher, so it's going to be negative 4K. All right, so that's going to be our coordinate difference. Now we're going to figure out the distance. So this is 10.4, 9.6. Add together, it's 9.6 square. Then we're going to plus 4 square, and then plus 0, right? Let's see what we got. 9.6 square plus 16, and we take a square root of that. We got 10.4. Not bad. So 10.4 meter, and then we're going to simplify this term. I term is canceled out since it's a 0, and J term is negative 9.6 divided by 10.4. I'm sure there's a way can be simplified. And we'll just write it down as it is as right now. The K term is going to be negative 4 over 10.4 TBD K term. All right, I think it's time to simplify. 9.6 divided by 10.4. We got 12 over 13 negative TBD J. Then 4 over 10.4, we got 5 over 13 TBD K term. All right, so we got all the three. One last thing is the weight of the fish. Weight with a hat. Well, we talked about that in the last video. The weight is going downward at Z direction. So it's negative. Z direction take K. So it's negative K. That's the direction. Do we know the magnitude? Yes, 1960 Newton. Then we have those 4 forces in IJK term. Then we're ready to construct our equations. Sum of X. Our X direction, we're going to use green. The first one, negative third TAB. How about TBC term? Negative TBC, third. Then how about TBD? TBD has no I term, and so is weight has no I term, so that's just in the equation 1. Then equation number 2. Y direction. We're going to use blue. So this is the Y component for TAB. 2/3 of TAB. Then TBC, we have negative 2/3 TBC. And how about TBD? TBD does negative 12 over 13 TBD. That's, how about weight? Weight has no J term, so that's at 0 equal to 0. Then the last we're going to look at is going to be our Z term. TAB has a Z term, 2/3 TAB. TBC also. Then TBD indeed have a K term also, negative 5/13 TBD. The weight has it, and it's waiting to be put it in there because you didn't show up on X and Y, right? And that's going to be equal to 0. Then you got equation 1, 2, 3. Then we can put into our equation solver to find the answer of those 3 unknowns. So I'm going to take a picture and we can go to Wolfram to solve it.
What?
So now we're going to Wolfram Alpha and put those equations there. And there are 3 unknown, TAB, TBC, and TBD. Well, let's just use ACD, I guess. ACD to define the variable, okay? So negative 1/3 negative A over 3 minus negative C over 3. That equals 0, first equation. Second equation, 2 over 3, A minus 2 over 3, C minus 12 over 13, D. That equals 0. And the last one will be 2 over 3, A minus 2 over 3, C minus 5 over 13, D minus 1960. That equals 0. All right, that's what we got. Enter. Let's see what we have. And then verify this input right here. See if it looks right. And looks pretty good to me. And here's the equation answer. And that will be our answer for it. I'm going to take a picture also. And then go back to our note. So I went back to this OneNote and write down our answers. So this is our answer for ABC, and which is our tension. And we get negative value here, which means the true value for BC is going upward. But we don't need to change because the FBD is pulling downward and we get negative value. That already say the true direction is going upward. That's all. I'll see you next time. Bye.